here. Maybe a few words of introduction. I haven't built an RWA protocol. I have spent more than the last 7 years building, scaling, and effectively exiting an online fraud prevention platform, which made me understand a thing or two about what can go wrong in terms of financial services offered online. And I wanted to take a bit of your time today speaking about securitization workflows and, most importantly, how they could be improved down the road with additional verifiable data sources. So let's take off. So let's not pay too much attention into parameters, and probably there were different versions of these numbers. The key message here is that, and looking at the number of attendees today, real-world asset as a segment is meant to grow massively. And obviously the question is whether it will grow 10, 20, 50x over the next years is a little bit secondary. What's most important to us, and what we are trying to understand as pragmatists, is what is effectively blocking the mass adoption that we all believe could happen one day when it comes to real-world assets. And there are a few things. Oh, I see that the slides are not showing everything, unfortunately. So you'll need to bear with me. Effectively, there are a few components of the securitization workflow that could benefit from additional data. And maybe just going through some of the steps, I believe that the first one is effective collateralization. So effectively answering a question, how much is the underlying asset worth? And it would be a very simple case in terms of a stablecoin, because that's very straightforwardly defined. But if we are talking about more complex real-world assets, that will be a very dynamic problem. And the question is, how do you want to acquire information about and obviously then trust it about how much this underlying asset should be priced at, so that you can maintain the healthy collateral. And this is obviously generating a lot of potential issues. The second aspect that you don't see exactly on this slide is regarding identifying who the actors are and proving that the ownership of the asset is really associated with what is about to happen. And trust me or not, there is a lot of fraud happening, and especially the nascent markets are attracting a lot of very smart individuals trying to figure out how to extract some value from the system. And the third one, which is the least attractive for many, but equally important, is effectively being in some sort of line of compliance with the formal and regulatory expectations. So any protocol that is conducting a particular workflow needs to make sure that their operation will not be halted because of what they do. What you're not seeing at the bottom of this slide is effectively that our understanding of, and talking with a few players of this space, is that all of that today is happening with a lot of PDFs, a lot of emails being forwarded, a lot of Excel sheets, a lot of documentation that is being manually processed by the operators, which is obviously generating a lot of risks when you think about exposing it to the broader community of the market. And the way things are happening and how off-chain actually securitization is happening is also very far from what some of the values within the blockchain ecosystem we have been entertaining for several years, and some of them are named here. Again, sorry for the slides, so you need to believe me what's really presented there. So the first one is regarding the effectiveness, and I'm a quantitative economist, and I deeply believe in the utility. So we will be able to attract mass adoption of users and customers, and I'm not only talking about institutional buyers, because these at least listening to what is happening during today's event, their needs are somewhat catered to. Like, there seems to be a lot of offering pertaining to the larger institutional players. I'm talking to an average individual consumer that would or should be also included in the offering that we are all imagining. And then the question is obviously, how can we make the workflow set up so that so that all the data that are available out there about these individual customers could be leveraged during the securitization workflow. The second aspect is actually regarding making sure that we are not doing things manually, but we are actually relying on more and more permissionless ways of treating information. This is the underlying idea of blockchain technology, and it is, to be very honest, we are quite far from getting there. And the last aspect, which again is not fully visible here, is associated with the privacy preservation. Like, there is a bunch of data sources that you can access, but typically these will be oracles that are displaying some sort of public information. What about all the relevant private information that could be leveraged for better securitizing or for reinforcing the securitization workflow? We do believe that with the recent advancements within the applied cryptography field, we are able to approach the stage of offering much more privacy by design. So maybe a few words about what we are doing and what verifiable data infrastructure is. Effectively, there are certain data sources that you can think about, and then there are certain features that a smart contract developer can use directly from their Solidity contract. And some of the data sources that are very important for us are very heavily present in everyday life, and we do understand that also they are very present within most of the securitization workflows out there. The first information is coming from emails. Like, email is a beautiful invention. It's the channel of communication of Web 1 and Web 2. Effectively, a lot of trust is being transmitted via email. With the right ZK techniques, you are able to extract part of the information of the email and convert it into an actionable on-chain claim, which could be accessed directly from your smart contract. The second source of data is associated with what kind of data is being displayed within our browsers, or in general behind the HTTPS protocol. So again, there are certain applied cryptography techniques that allow you to attest the correctness of the information that is being displayed on the browser or that is accessible via the API. And last but not least, it's obviously a lot of information is already sitting on chain, but I'm not sure how many of you try to write a smart contract and access history of Ethereum, for instance. It's not so simple. If you're operating within the last 256 blocks, it might be rather straightforward, but if you want to really go into the history of activity and then try to search for some more granular pieces of information, it's really complex because how this database structure is built. So again, there are some techniques that we've been developing that allow you to access almost as simply as writing an SQL query to be able to access this historical information directly from the level of smart contract. At the end of the day, these convert into smart contract features. Very simply, you could just reinforce your securitization workflow with these very granular proofs that can be trusted and can be consumed in a permissionless way, in a privacy-preserving way. That's the beauty of zero knowledge. There are a number of use cases, and again, slides are continuing to fail me, but maybe just bear with me for a second. This picture probably is quite basic, but one of the features, or two examples of the features, are associated with leveraging proof of reserves or proof of ownership. And effectively, on the right-hand side of the slide, you are seeing that a particular custodian might be generating some emails confirming that they have a particular position, so that the protocol, the fund operator, and then the entire protocol is operating in the safe situation. Obviously, there are several alternatives. This kind of proof or confirmation could be a signed PDF, or it could be a dashboard, it could be an Excel file. At the end of the day, what we are saying here is that this entire information exchange could be done by using on-chain claims that would be generated directly at the level of custodian here and transmitted to be leveraged permissionlessly from the Solidity smart contract using our infrastructure. We also do believe that there is a big use case for making decentralized privacy-preserving credit scores. Again, banks are publishing a lot of information in terms of what's, for instance, the bank account statement. If this is an Web2 platform, you're able to generate a proof directly with your browser, and based on this proof, you would be able to transmit this on-chain claim directly to the protocol and make your securitization work. There's a bunch of for other classes of RWAs. There's more and more chatter around receivables financing. There's a bunch of SaaS platforms that are used for managing invoices and making sure that the payables are coming in. Again, directly from the browser, you could generate proofs that a particular title to revenue is valid and unpaid. And again, that could be transmitted directly to the RWA smart contract. Thinking about mortgages, again, a bunch of jurisdictions are already moving to having digitized versions of land house registries. And again, since these are usually sitting behind HTTPS, you could use them to certify a particular real estate asset ownership and use it directly instead of dealing with screenshots or PDFs. The last example is regarding the secondary marketplace. There is a big story associated with the Carta. It's a platform for managing cap tables. Maybe you know them. And the founder was explaining for several instances how he was trying to build a marketplace for secondaries and why he failed in this. The beauty of the situation and that showcases the use case for our verifiable data infrastructure is that as a user of this platform, so like an employee that is granted some sort of stock options, you're able to access your Web2 dashboard. This is data confirming that you own particular stock options. Directly in the browser, you would be able to generate a cryptographic proof of your holding, and this information would be then transmitted to a pool of assets that would later be matched against some sort of demand for the security. And this just demonstrates how easy or technically easy it would be to create a new generation of marketplaces based on the data that is currently siloed within Web2 platforms by offering this proof generation directly from the browser. This slide was supposed to talk about the oracles and the limitations of oracles. Probably the most common architecture that you might be hearing about when it comes to data sources. Oracles are great. We support them greatly, but they are predominantly great for dealing with public information. If you want to access something that is not secret to anyone else, go for oracles. But we do believe that RWA securitization would benefit greatly from injecting all the private information that is currently sitting within Web2. And this is possible today with the applied cryptography that we have at our disposal. That's it from me. I'm a little bit ahead of the schedule. Sorry again for making this slide following very, very difficult. If you would be interested in learning more, please follow us or contact me directly. Happy to send a proper version of this presentation to you later. Thanks a lot for your attention.